There we go. Now that'll start recording my voice, maybe. And maybe. Now let's close this over here as we get ready. Stop it, stop it. The joys of dealing with machines. They like to fight with us. Okay, share screen, and let's do desktop 2. Share. Okay. So if people say something in the chat, I still can't see it because I can't figure out how Zoom works, apparently. It keeps hiding the chat. But that's okay. You know why? Because we make do. That's part of life. Make do with the difficulties. So now we will go through, and today we are going into 2.6, part 2. Now, on the lessons and things, I have these combined as one lesson. You can do the homework in 2 parts if you want. Remember, you get unlimited attempts on the homework. So don't stress it. Don't worry about grades. They're just there for your reference point. You know, how am I doing in this? If you get an A+ or a D+, what you master, just take your time. Do your thing. Skip anything you don't want to do that you already know. If you've mastered it, just take the test on it. So if it's ever annoying you in the system, chances are it'll annoy me. We'll get it taken care of. Okay. So today we are doing 2.6 part 2, adding fractions with unlike denominators. So when I think about this lesson, I like to think about an algorithm. If you don't have this written down, I highly recommend you do. This set of steps will always work. Is it always the most efficient? Not necessarily. In fact, oftentimes, no. But we have this for every single time. It'll get me where I'm going regardless. So even if it's not the fastest, it is reliable. So this is called adding fractions with unlike denominators. All right. So to add fractions with unlike denominators, and if you find yourself in need of notebooks, we have extra in the red pen, along with pens if you need. Help yourself. If you find yourself at home needing these, just ask Scott for them. We can hook you up. Our goal is to help you with all the supplies you need. Don't sweat the small stuff. So we have step 1, and that is factor denominators. Step 2 is to declare the LCD. Step 3 is the multiplication identity. Step 4 is to add or subtract numerators. Well, just rude. See, that's why I don't like the Zoom. It's always interrupting me. Bad Zoom. Do what you're supposed to. Why would I put the controls on the same screen that I'm sharing? Seriously, thank you. I appreciate that. All right. 2.6 part 2. And of 5, which is factor reduce. Now, when you're doing your, going to need paper. See me, I've got plenty up here. Don't try to squeeze too much into one area. It gets cluttered and it's hard to keep track of. Last thing I want is for people to save a bunch of paper and not understand the math. Then we have to use more paper. Entertaining thing. Up here. And we're going to look at, oh, how about number 3? Doesn't that look precious? 3/8 plus 1/6? It doesn't look too bad. I believe that's what first taught to do this. I was taught, okay, look here. 6. Okay, I see 6. Here. 8. I see. Now find what they have in common. They're not consistent. Oh, I don't know. Yeah, like so. Like needing to see that. There you go, sir. I'd struggle because, as I got better at it, I could start to see it, but not always. I have to see it. I don't have to be aware of anything. I just stay to this algorithm. And an algorithm is just a set of and achieve the same type of result. I'm not going to get something wonky. You know, if I go sit in my car, I don't have pink hills. I wouldn't expect that. I have never had anything that wasn't a culinary mushroom, but thank you for checking. Right. Well, that would be an unexpected result. I mean, I'm sure there's a possibility of it, however remote. It might involve a doctor and someone sick in editors. I'll see it. If you can't see it, tools you need if you go into step 1. And I'm all ears. I'm only interested in primes because I want the bricks in the wall. I want to tear this apart, look at it as bricks, and then do what I want. Too. And how I got that is if I take 8 and I say, okay, 2, 8 divided by 2 gives me 4. 2, 4 divided by 2 gives me 2. 2, 2 divided by 2 gives me 1. And I'm done looking for primes because 1 shows I'm done. In order for a number to be prime, it has to be greater than 1 and divisible only by itself and 1. Then I'm going to do the prime factors of 6. So 6, it's divisible by 2. 6 divided by 2 is 3. 3, that gives me 1. So I'm people. For anyone who's not aware, I'm making a joke about right. Higher common denominators, it just means I'll have to, and my goal or not is efficiency. The more steps I introduce, the more likely I am to have a failure, the more likely I am to have an error. Now I'm going to take advantage of the idea that any number divided by itself is equal to 1, as long as that number is not equal to 0. See people try to. And I'm going to take advantage of the fact that any number times 1 is just itself. Identity just says you multiply a number by 1, you end up with the same value. And a denominator. Oh, yeah. I mean, seriously, we were going to do right? Okay. So now I'm going to do 3 and 2 times 2. Now I've got 3 times 3 gives me 9 over my LCD. Some the reason I have seen people get caught into a loop where they go around and around. Because if you leave it in factored forms, you're going to find that there are things that then you've got to do. Yeah, brain, put it aside on that shelf for a minute. And by doing so, that'll make it easier. When you hit algebra, if you're doing algebra with these, oh man, is this so much easier. A's, B's, C's, and see it. So now I'm going to say plus 2 times 2 is 4 over my LCD. So 2 times 2 is 4 times 1. Math is had nothing. So now we're going to say, okay, next step is to add or subtract the numerators. And why do I say this is for adding fractions with unlike denominators? Well, that's simple. Subtraction is addition of the opposite. Isn't that rude how I'm always referring to these definitions? Should think you got me. 9 plus 4 gives me 13 over my LCD. Now I can put that in, and that is 2 times 2 times 2 times 3. And I'll just double check that. Matter because it's now 13 is prime, so I'm going to factor it up, nothing to factor out. Reduce, nothing to reduce. Now I combine, I write this as 13 over 2 times 2 is 4, times 2 is 8, times 3 is 24. And I'll factor it, reduce everything, and then I combine it together. So now let's have a look that might be a bit less pretty. I'm thinking number 6 looks. So here we've got this, and we can work right here on the sheet. And remember, I have all right. So on this, I've got 8 and 2. I can do it, and it is easier. But I'm built to have the same size pizza. It's a funny thing. You wouldn't believe how often when you get delivery, your pizza has on its way to you. Actually, but because drive all kinds of unknown hazards, including holes in your driveway. So if you don't like your pizza shaken, not stirred, keep the holes out of your driveway. Back to the lesson though, now that we've had a quick brain break. We want to use this algorithm. We're going to factor the denominators. So we're going to say 26 over 3 plus 27 over, and this is over 4, so 2 times 2. Now I'm going to declare my LCD. That's my next step. I'm going to pick on a side. It doesn't matter which. I'm going to pick on the right again. You know why? There's 2 factors. Less writing this way. 2 times 2 And then I'm gonna look at it. What am I missing? Oh, I'm missing that 3. So times 3. Now I put up my parentheses to use the multiplication identity. Any number times 1 is itself. Any number divided by itself is 1, except for 0. Only crazy people try to divide by 0. It doesn't work. So now we're going to put on this side, we're missing over here. Look, I'm missing a 3. If only I had a 3. And on this side, I'm missing the 2 times 2. So I'm just going to write that 2 times 2. And that one's a 3. What I do to the bottom, I have to do to the top. Otherwise, I'm making up math. If we were going to do that, we'd do that with money. So 2 times 2. And now I get 4 times 26. That's going to be 80 plus 6. Ah, 6 is 24. Times 2 is 8. Wow, look at that. Common core math right there. All right, let's see. 27 times 3, that's going to be 81. How do I know that? That's because 8 or 3 to the 4th is 81. Or 9 times 9 is 81. How about I properly notate that? Yeah, that'll help a lot. See if I right, LCD. I specialize in math and I almost blew it on that one, huh? Yeah, LCD, it's so much nicer. It stays clean. All right, so now we've got 100. Whoa. Let's try that again. 185 over our LCD because we're going to combine those numerators. And now we're going to say, okay, 185. Well, let's factor that bad boy down. I definitely, oh, let's try that again. There we go. 185 is divisible by 5. That would be what? 20, then 85 would be what? 16, so 36. Yeah, don't do that in our head. It'll cause pain. So we'll do here, 5 will go into 18 3 times. 3 times 5 is 15. Oh, I would have gotten there too. Bring down the 5. So we've got 7. And 37 is prime. So now we have 5 times 37 over our LCD, 2 times 2 times 3. And that's not going to reduce anything out. And so we get 185 over 2 times 2 is 4 times 3 is 12. Now I want to put that back into a mixed number. So I'm going to do the division of 8 times 1 fifth, 5. So 15 and 5 over 12. Efficient route there. No. The way the sentence is, if you thing as the way. And so from that, we get to 4/9. Times 3 is 3. 1 times 2 is 2. Times 5 is 10. Two times 5. On the right, because it's got more. I'm going to 5 and 5's already covered. So 5 and 5's covered. I don't have to stress it. I've got. So one more time, I wrote this one right up here. See, there's a 5 and 5 here. All the terms down here are covered, all the factors. So I don't have to worry. I found my LCD, I don't have to add numbers or anything. Now I'm going to go to the multiplication identity. I'm just going to put up parentheses on this side because it already matches. This side's missing. Remember, what we do to the bottom, we do to the top. Now I've got 2 times 1. On these, the fractions with the order of operations, we're going to keep to that. On these complex fractions, we just consider these. When you have independent math going on up there as its own grouped item. The denominator, keep it as its own grouped item because they're separated. You all forgot. So this recording turns out better than the last. Channel. Thank you so much for coming. Any questions here in chat? Nope.